Today's lesson on probability focuses on finding the probability of independent and dependent events. Events are independent if the occurrence of one event does not affect the probability of the other event occurring. And events are dependent if the occurrence of one event does affect the probability of the other event occurring. Let's do a few examples to see what that means. Tell whether each set of events is independent or dependent and explain your answer. A dime lands heads up and a nickel lands heads up. This would be independent because the result of the dime has no effect on the result of how you flip the nickel. In our second example, you choose a colored game piece in a board game, and then your sibling picks another color. Your choices would include 4 colors, but after you have chosen a piece, say you choose the red one, your sibling would only have 3 choices. This, therefore, would be a third example. A die or a dice lands showing an odd number, 1, 3, or 5. It is rolled a second time and lands showing a multiple of 2, 2, 4, or 6. Your first roll and your second roll have no effect on each other. Therefore, the events would be independent, because each roll of the die has no effect on the other. In this final example, one student in your class is chosen for a project. Then another student in the class is chosen. If you have 10 students in your class to choose from, the first time you choose, you have 10 options. However, once one student is chosen, when you're choosing the second student, you now only have 9 students to choose from, or one less. So this event would be dependent, because once the first student is chosen, the group to choose from has changed. Again, independent events means that each event are not affected by each other. Dependent events means that the occurrence of one event does affect the probability of the other one occurring. Now, once we've determined if the two events are independent or dependent, that will change how we calculate their probability of both events happening. If the two events are independent and they don't affect each other at all, we simply multiply the two probabilities together. The probability of event A happening times the probability of event B happening. However, if they are dependent events and the second event, B, has a probability that changes based on A, we multiply the probability of A as normal, but times the probability of B after A has occurred. Let's see how this plays out. The directions ask us to determine whether the events are independent or dependent, and then to calculate the probability. Example 1. An experiment consists of randomly selecting a marble from a bag, replacing it, and then selecting another marble. The bag contains 7 blue marbles and 3 yellow marbles. What is the probability of selecting a yellow marble and then a blue marble? On my first draw, these are my options. Now notice that on my second draw, after I have drawn a yellow marble, I put the yellow marble back into the bag, which means that my second draw actually has the same number of options as the first draw. Therefore, those two events would be independent because my second draw is not affected by my first draw. Because they are independent events, I simply multiply the probability of the first draw times the probability of the second draw to find the probability of both events occurring at the same time. Now, the probability of the first draw of getting a yellow marble would be 3 out of 10 total marbles. The probability of getting a second draw a second draw being a blue marble would be 7 out of 10 marbles. I multiply those two probabilities together. Remember, when I'm multiplying fractions, I multiply the tops and then I multiply the bottoms. You do not need a common denominator when you are multiplying fractions. My final probability would be 21 over 100. The second example, when a person rolls 2 die and they land showing the same number, we say the person rolled doubles. What is the probability of rolling doubles 3 times in a row? Well, my first roll does not affect what I roll the second time or the third time, so these events would be independent. The following chart shows us probabilities of rolling 2 dice. Notice I can roll double ones, double twos, double threes, double fours, double fives, or double sixes. There are 6 total ways to roll doubles out of 36 possible roll outcomes. Therefore, the probability of rolling doubles the first time would be 6 out of 36. The probability of rolling doubles the second time would be 6 out of 36. And same with the third time because they're independent events. To make multiplication easier, I'm going to reduce 6 over 36 to be 1/6. Multiplying the tops together, I get 1. Multiplying the bottoms together, I get 216. So the probability of rolling 3 doubles in a row is 1 over 216. In this next example, there are 7 pink flowers and 5 yellow flowers in a bouquet. Jane selects a flower at random, and then Leah selects a flower at random from the remaining flowers. What is the probability that Jane selects a pink flower and then Leah selects a yellow flower? Well, notice that after Jane has selected a pink flower, Leah's options are affected. She no longer has the same number of flowers to choose from. Because Leah's options are dependent on the flower that Jane has picked, these are dependent events. The probability of the first pick for Jane of getting a pink flower would be 7 pink flowers out of 12 total flowers. 7 out of 12. The probability for Leah to choose a yellow flower would be a total of 5 yellow flowers. And note the total number of flowers is no longer 12. Now it is 11. So 5 out of 11. So notice that second probability total was affected by the first probability's occurrence. Multiplying straight across, 7 times 5 is 35, and 12 times 11 is 132. My final probability would be 35 over 132. On this next example, an experiment consists of spinning a spinner twice. What is the probability of spinning 2 odd numbers? Well, notice that my first spin and my second spin are not related at all to each other. That makes them independent events. So I simply need to calculate the probability of the first spin and multiply it by the probability of the second spin. The probability of spinning 2 odd numbers, meaning your first spin is an odd number, 1, 3, or 5, would be 3 out of 6. The probability of my second spin being an odd number would also be 3 out of 6. Before I multiply them, I'm going to reduce to be 1/2 times 1/2, and that would equal 1/4. The probability of spinning 2 odd numbers would be 1/4. In this example, a bag has 10 red marbles, 12 white marbles, and 8 blue marbles. Kind of looks patriotic. 2 marbles are randomly drawn from the bag. What is the probability of drawing a blue marble and then a red marble? Now notice, my first draw does not have me replacing the marble. Therefore, the options to draw from on the second draw will be different than the options on the first draw. That makes this dependent events. And we will calculate the probabilities of each. The probability of the first draw, meaning drawing a blue marble first, would be 8 blue marbles out of 30 total marbles, 10 plus 12 plus 8. 8 out of 30. The probability of the second draw after that blue one is removed would be drawing a red marble on our second draw would be 10 reds out of now 29 marbles left, no longer 30 because one has been taken out. So our second probability would be 10 red marbles out of a total of 29 marbles left to choose from. Reducing down, I could make this 4 over 15 times 10 over 29. Multiplying straight across would give me 40 over 435. Now notice this could still be reduced by a power of 5. 40 divided by 5 is 8, and 435 divided by 5 would be 87. Always leave your probabilities in reduced form. Our next example says that we are randomly selecting 2 cards from a standard 52 card deck. Here are the 52 cards possible. What is the probability that the first card is a jack and the second card is also a jack? Now notice it does not tell us that we're putting the jack back into the pile for us to draw from. So the first time we draw a jack and the second time are going to be dependent events because we will have a different set of cards to draw from. The probability of drawing our first card as a jack, well, there are 4 jacks in the 52 card deck. So our first probability would be 4 out of 52. Now because we did not put that jack back in and we have already chosen, say it's this jack, and we already got it, now there are only 3 jacks left that we could choose from. So 3 jacks out of now 51 cards left in the deck would be our second option. Multiplying across would give me 12 over 2,652, which could reduce by 12 to be 1 over 221. The probability of choosing our first card a jack and our second card of a jack would be 1 over 221. Our last example also deals with a deck of cards. We'll erase off this X now that we're not using that other example. It says, you randomly select 2 cards from a standard 52 card deck. What is the probability that the first card is not a heart and the second is a heart? Now notice, again, we are not replacing our first card before we draw our second, which means that the second draw will be affected by the first one. These would be dependent events, and we'll calculate the probability first that the first card is not a heart. Well, this row right here is all hearts. There are 13 different hearts, 10 regular and 3 face cards. So 13 of these we would not want to draw. So the probability that the first card is not a heart would be crossing off all of the hearts, 13 plus 13 plus 13 options out of 52 cards in a deck. 13 plus 13 plus 13 would be 39 out of 52 choices. So that's the probability that the first card is not a heart. Now, the probability that the second card is a heart is going to be the opposite, right? There are 13 cards that are hearts, so our top number will be 13 that we can pick from. However, notice that once we have chosen our first card that wasn't a heart, we now only have 51 cards left in our deck. Multiplying across, 39 times 13 gives me 507. 52 times 51 gives me 2,652. And I can reduce that down to be 13 over 68. The probability of choosing a card that is not a heart first and then a card that is a heart second would be 13 over 68.